Hello my students, how are you? You must be fine condition, and today we are going to start one of the interesting chapter and the most basic or the fundamental chapter of the physics, that is the scalars and the vectors. As the name scalars and vectors came to your the side, you are mostly acquainted of that one. That means in the Odia medium or in the English medium, regarding the scalar and the vectors you have some basic ideas. But today we will discuss that, including that basic idea. If some necessity idea is not included, then we cannot say that with that definition it will be that type of the physical quantity. So, in this chapter we are going to discuss about what is the scalar and the necessity of the vector, the representation of the vector, angle between the vectors, the difference between the scalars and the vectors, and the types of vectors or the classification of the vectors. So, now we are going to discuss about the scalar and the vectors. First the question is, what is the scalar? As the name is the scalar, mostly of the Odia students, they will feel that what type of this physical quantity. But in the first chapter, means on the previous classes, we came to know that a physical quantity is always a measurable one with the certain numerical values, with its the unit. So, we represented a physical quantity with a symbol of the PQ, physical quantity, with the symbol of the PQ. PQ means the physical quantity, PQ, that is the physical quantity, physical quantity. And what is that physical quantity? How it to be represent? With the n and the u. This n is what? N is the number, or you can say the amount. U is the unit. So, as I said, a physical quantity has its the number or certain magnitude with its the unit. Suppose I will say this is the marker. This marker has its the certain length. Suppose this is the length of the marker. So, this is the length of the marker. Suppose this length is the 5 centimeter, then this 5 is corresponds for the n, and the centimeter is corresponding for the unit. So, if this is a 5 centimeter, means this is a physical quantity. So, by using that physical quantity, what we measure? That is the length of this marker. Suppose someone say, what will be the mass of this marker? And the mass of this marker, suppose that is equal to the 20 gram. So, 20, it is the number or the amount, and the gram is its the unit. So, when the amount with the unit are taken together, that is called the scalar. So, scalar are those physical quantities PQ which have only magnitude, which have only magnitude. So, magnitude means what? Magnitude means your value. Suppose here of the 5 centimeter. So, what is its the magnitude? The magnitude is of the 5. This is the 20 gram, means it is the magnitude of the 20. So, only the magnitude. So, can you say that this 5 centimeter is towards the east, this 5 centimeter towards the north south? There is no direction of that one. Similarly, for the mass of that marker, mass of that marker is the 20 gram. Can you say the mass of the marker is 20 gram towards your the Mumbai direction, towards your the Haryana direction? That we are not saying. So the physical quantities which have your the only magnitude, that is known as your the scalar. And what we are observing in this universe, suppose you are moving on your the road, you are looking for your the a car. Suppose the car has its the length, and the length of the car is the 4.5 meter. So if the length of the car is 4.5 meter, what is your the length? Length is its the amount, which is its the physical quantity, and your the 4.5 is its the magnitude, but it has your the no direction. Next, if you go for your the mass of the gold bar is your the 1 kg. A bar is looking on your the figure, that is your for the gold. So here the mass, that is your the physical quantity, which has its the magnitude of your the 1 kg. Similarly, if you go for your the time, you are making your the, suppose you want to know what is the time now. The time is your the 12 hours with your the some seconds it is provided. So that 12 hours with some seconds, that is its the magnitude, and your the rest one is its the physical quantity, that is your the time. Then is your the temperature. The temperature of your the certain body, that is your the 36.3 degree of the Celsius, suppose say. What is the normal temperature of the human body? That is the 37 degree Celsius. And generally the temperatures which we are saying in your the common knowledge, that is in your the Fahrenheit. And in the Fahrenheit, the normal body temperature is 98.6 Fahrenheit. That is 98.4, but now due to your the global warming, that is taken as the 98.6, that is the normal temperature. So a scalar is that physical quantity that has only your the magnitude. So I have given you the different types of the scalar quantity. One for its the length, one for its the mass, one for its the time, okay, then one for its the temperature. So these all are your the physical quantities which have only your the magnitude, and they are called as your the scalar. So these are its the examples. Are you clear, my students? So the scalar means adisha. In Odia, that is called your the adisha. Adisha. Disha means your the diga. There is no direction. That quantities are called your the scalar. In Odia mediums, in the 9th class, you probably know what is your the scalar. ଯେଉଁ ଭୌତିକ ରାଶି ମାନଙ୍କର କେବଳ ଏକ ନିର୍ଦ୍ଦିଷ୍ଟ ମୂଲ୍ୟ ଥାଏ, ତାକୁ କୁହାଯାଏ ଅଦିଶ ରାଶି. So this is your the scalar. If all the physical quantities can only it has your the magnitude? No. Suppose I will give you some of the examples, and from that we will come to know about your the vector. So vector necessity. Why the question of the vector being your the arises? Why you came to know about your the vectors? So vector are what? Those physical quantities which have the magnitude as well as with the certain things, and that certain thing only you know about its the directions. But today we will come to know that with the direction, some necessity condition to be associated with the vector, then only we will say that if that conditions are to be satisfied, that will be treated as your the vector quantity. Let us take one of the example. Suppose there are the two friends. One friend is your the rich one, another one is your the poor one. And that rich friend is now fighting with his the last breathing. So he said to his friend that, so my dear friend, the treasury which I have, that already digged in your the near to a tree, and which is situated the 5 meter from the tree. Then the friend asks, where is that tree? Now near to your the house there is a park, and away from that park there is a large area in which at the one side there is a mango tree. So as that friend heard that one, he left the friend and go ahead. The friend is calling, please listen brother, please listen brother. he is not listened to his words, and he went. And went where he went, and he reached to that space, means near to the park. There was a tree. There was a tree. And he came to know that near the park there is some tree, means the mango tree. He said that there is a mango tree, and near to that mango tree he already digged his the treasuries, means your money, the valuable goods, means your the gold, your ornaments are already inside your the soil. So while he gone and seen that the mango tree is there, he started to digging. He started to digging, but nothing is obtained or nothing is found. He started here. He started digging. He started digging. Everywhere he started to, but the space is your the large. When he is going to your the digging and digging and the digging, nothing is coming out. Are you following my the points? And if at that time the friend who is calling, please listen my brother, please listen my brother, if he came and to know that in which direction that treasury being your the put inside your the soil, then from that tree he can move to that direction. But he already said that I just dig it 2 meters away from that mango tree. So from that mango tree he dig to the 2 meters. He gone here, he gone here, he gone here, he gone here, but nothing being happened there. Only the 2 meters he came to know, but no direction. So if the direction being provided from the mango tree towards the east, or from the mango tree from the right making your the 30 degree, if you will go 2 meters and dig inside, or you will take the soils from that position, then you will find that one. Though he is aware of the direction where that ornaments or the valuable goods are there, so it makes him to wear the large labor. Are you clear to my friends? So this is your the one thing. Suppose you will go for your the second example. Suppose second example, there is a square. The 4 ways are here. Suppose your house is here. Your mother said the guests are coming, so you go to your the square, and near the square there is a sweet stall, and you purchase some sweets. And immediately he gone to that position. And here there are the 3 sides. Where the shop is there? He asked one person, so respected brother, where is that sweet stall? He said that the sweet stall is your the 200 meter ahead. 200 meter. As he had the 200 meter, he gone ahead 2 meter. 200 meter he gone. But there is no shop is there. Again he asked one person, so where is that sweet stall? He said that that sweet stall is now the 400 meter. So without asking anything, he gone near the 400 meter. So why he said 400 meter, my students? Because he already came 200 meter from the square, and to the right the sweet stall is there, and that sweet stall is the 200 meter to the right. Therefore he said you came already 200 meter from the square, and that is 200 meter to the right of that square. Therefore he said you already came 400 meter. Therefore he said that the shop is at the 400 meter. He never asked 400 meter towards the right or towards the left. Are you clear? So the 200, 400, what are that? That are the magnitudes are coming. 200 meter or the 400 meter, that is the units. So the magnitude with the units, that will give you the physical quantity. But here that physical quantity has no importance. So if the person is came to know the direction of that one, then from the square it is 200 meters to the right. If he asks to his mother that where is that sweet stall? Now as we go to the square, to the right there is a way, and if we go 200 meters towards the right, there is a stall which is the sweet stall. Means to the right, to the left, ahead or the backward, these are all the directions. So, if only the physical quantities are came to know by your the formula of your the nu, it will never treated or satisfy the position which we want to be. Therefore, at that cases some direction is necessary. Therefore, the vector are those physical quantities which have magnitude as well as the direction. So, vectors are those physical quantity, quantities means more than quantities, more than one quantities, which have magnitude as well as direction. जो दिस डिरेक्शन मीन्स योर द दिश से भेक्टर को पिले कहा जाए सदिश. भेक्टर्स आर योर द सदिश. Disha means your the direction, sa means with, means sah. So, the direction with the direction, if the magnitude is there, then that is known as your the vector quantities. So, we came to know what is your the vector. Vector means those physical quantities which have magnitude as well as the direction. Suppose there is a globe. On the globe, the different countries are there. So, from one country to the another country. So, from one country to another country is situated either towards its the left or towards its the right, means towards the north or towards the south or towards the east or towards the west, making your the certain angles. So, on your the screen you will find that there is your the two countries. So, one is your the California, another one is your the North Canada. So, the distance between that two means it is situated with the angle of such degree with the that one, means the position of the one country with the another country makes your the certain angle. That angle indicates its the direction. So, the position of your the California for your the North Carolina is your the 3600 kilometer. If one will say, means 3600 kilometer means only magnitude, then it has your the no direction. If the 3600 kilometer towards this direction means or in this direction means in west or in the west, in the east or in the north or in the south or the northeast or the southwest likewise, then that is called is the vector quantity. So, if the vector quantities are there like your the scalar quantity, what will be the examples of the vector quantity? Please remember to your the school levels you came to know that examples will be your the displacement, vistapana, displacement, acceleration, force, okay, momentum, velocity, etc. These are your the vector quantities. So, this is your the scalar, this is your the vector. So, the scalar have only your the magnitude, but the vector have your the magnitude as well as the direction. If the direction is there, then the question comes how that vector to be your the represent. Next we will go representation of the vector. Representation of a vector. Representation of vector. So, what is a vector? Which have its the magnitude and the direction. Generally, a vector quantity has your the magnitude as well as the direction. Suppose it is an arrow. This arrow, suppose this end is your the A, this end is your the B. This end A is called as your the tail side, this is called as your the head side. So, why it is given the head? Head means it must have its the direction, munda. So, this is this type of the symbol you see is here. So, the symbol of this one is where directed, that is its the head side, and this is the tail side. From head side to the tail side means from head to tail, what is the length, that is its the magnitude. So, this is its the magnitude. It may be the 10 centimeter, 20 kilometer, or whatever may be the magnitude, but that magnitude depends upon its the unit. As the unit you will take, according to that you will say that that is its the magnitude. Suppose this is the length. This length I will say 5 meter. The same length can I be said that is the 15 meter. Sir, is it possible? Yes, it is possible. So, for the 5 meter, let I have taken here the 3 unit parts. This unit part I have taken as the 5 meter. This unit part, this is the say 6 meter. So, this unit part I have taken as the 2 meter. But one will say, no sir, this unit part I will take as the 5 meter. So, for whom this unit part is the 5 meter, there are the 3 such unit, therefore, that is the 15 meter. But for whom that is the 2 meter, likewise the 3 such units, for that is the 6 meter. So, this length if it is the 15 meter, then I will say that this vector of length 15 meter means it must have its the direction, it is directed towards the right from here the vector A, means from the position A. So, this arrow mark will show its the vector, and generally a vector it will represent with a single letter, say I will say that is the P, Q, R, X, Y, Z, whatever may be the single letter you will take. Over that letter if you will put an arrow mark, then that will be treated as the vector. So, if P is the vector, then it has its the magnitude. So, what will be the magnitude of that one? For that magnitude, you have to taken the modulus of that one. So, P vector modulus, that is also written as here the only P. So, only P means it is the magnitude, P vector modulus, that is also the magnitude. But the proper way to use that symbol is here that vector's modulus is its the magnitude. But generally we are saying that if it is the P means it is a part of the vector which is its the magnitude, that is here the P. Are you clear? What is the magnitude? But what is the direction? The direction as shown here, that is from here from this side to here that side. Means instead of taking likewise a vector, if I will take another vector is likewise, means it is its the initial point, it is its the final point. You see, this is its the initial, this is its the final. That initial is called here the tail, and the final means towards the direction where it is going, means that is its the munda. Suppose someone is going, means his or the her head is in that direction. A train is going, a train will moving in which direction? Where the engine is there. If the engine is making here the turn, the train is also the making the turn. So, the engine is the head, and here the other compartments are its the tail. The last one will be taken as the tail. So, this is also here the vector, and if we take a vector is likewise, it is going in this direction, this is also here the vector. If this vector you can say is the R vector, this can be you will be taken as your the A vector. Therefore, a vector always has a magnitude with your the direction, but that is not its the sufficient one. If we will go for the other examples, suppose the displacement from your the USA to your the China is your the such kilometer, in your the what direction is written on your the screen, that is your the in the east. So, the two places are there, but a particular direction is given when the line joining that two particular directions, two particular places, that is called here the displacement. As I said, you see, displacement is the example of the vector. Likewise, that displacement is nothing but one of the length, and that is called here the distance. That is called here the distance. The distance is here the scalar quantity. The speed is here the scalar quantity. So, generally we are saying that what speed the train is moving, with what speed that bike is moving, because the bike is not going in a particular direction and he continuously changes the direction. But when the aeroplane is going, we will say that the velocity of the aeroplane, because the aeroplane to be moved in a particular direction as the commanded by the control section, because the pilot will never find out the destination's point, because it is the large area. Therefore, he or the she always depends upon the control room. The control room is saying you have to move in this direction to making certain angle towards the right or the left. So, according to that, that is moving, means in a particular direction. Therefore, the plane speeds, we are saying it as your the velocity. So, the distance, the speed, like the distance it is the displacement, it is the speed, it is your the velocity. So, this is your the scalar one, that is the vector one's difference. But one necessity condition we will discuss now. So, from the scalar to your the vector, how they are different. This side is your the vector one, this side is your the scalar one. This scalar only have your the magnitude, but we have written the vector has your the magnitude as well as the direction. But this is not your the fully correct. And for the second condition, it to be satisfied, it should obey the vector law of addition. Vector law of addition. This is the most important condition. Vector law of addition. So, addition means the vector law of the different types we came to know in this chapter. One is the triangle law of vector addition, polygon law of vector addition, and your the parallelogram law of vector addition, and that type of the law it to be or the satisfied, then we will say that this is your the vector quantity. Suppose I will give you one answer, this one, this one, this one, this one. Suppose this is the current, and the current is coming of your the 2 ampere, and this is your the current of your the 3 ampere, and this is the current of your the 5 ampere. So, this 2 ampere, 3 ampere, they came to a point, then they will pass as your the addition of that 2, that is your the 5 ampere. But what we will say about your the current? This 2 plus 3 is equals to 5, it is the general form of your the addition, but that is not your the vector addition. I will now explain what is the vector addition. So, this 2 plus 3 is equals to the 5, but this is not your the vector addition, but the current has a particular direction, because the current is flowing in this direction, because it depends upon the direction of the wire, and according to that the current is flowing. So, if the wire is from north to south, the current is flowing from the north to south. Therefore, it has its the magnitude and the direction, but it is not your the vector quantity. If the similar type of the example, if you will take, suppose one is gone 2 meter from left to your the right, again he gone 3 meter from left to right. So, what total distance he covered from this to this is your the 5 meter. This is your the 5 meter. And the same example can be taken, one has gone 2 meter and again he has gone here the 3 meter, means from this to this is your the 3 meter, and from this to this is your the 2 meter. So what distance here the C cover? Again that is the 2 meter plus of here the 3 meter. This is your the 2 meter plus of here the 3 meter generally. And one has gone here the 2 meter, again he gone here the 3 meter. This is your the 2 meter, this is your the 3 meter. So what distance is gone from the initial to your the final? Of here the this one. Of here the this one. But this is not here the 2 plus 3, that will here the 5 meter. It is not of here the 5 meter, because it will satisfy here the Pythagorean's theorem. So what that Pythagorean's theorem states? If it is the base, it is the height, then it is the 2 square plus a 3 square root over. 2 square is the 4, 3 square is the 9, 9 plus 4 is the 13, 13 means it is lying between your the 9 and your the 16. If it is 9, then its the root over will be the 3, if it is the 16, its root over will be the 4, but this is the root over of the 13, means it is the more than of the 3 and less than of the 5, means in between 3 and here the 4, means starting from the 3.1 to 3.9 we will say. You see, here also the two things are added, here also the two things are added, here also the two things are added, but the result is not here the same. And here the 2 meter plus 3 meter, 2 ampere plus 3 ampere is here the 5 ampere. Suppose I enhance that angle between that two. This is your the 2 ampere and this is your the 3 ampere. And this is your the passing out, that is your the 5 ampere. And here the angle is this, here the angle is this, but these two angles are the different, but the result is coming here the same. But here the two things are here the same thing are the adding, but here the result is lying between 3 to 4, here the result is here the 5, and here the result will be here the 1. Means when the angle being here the different, the resultant distance or the displacement covered, that is your the different. But here as the angles are the different, the net value or the resultant value is remains here the same. So the example is, for here the current, it has the direction, though it is not satisfying the condition of here the vector law for the addition, therefore we will say that the current is not a vector quantity, so it is your the scalar quantity. But if it will satisfy the triangle law for the vector addition, then we will say that that is your the vector 1. Means this should obey the vector law for the addition, which is it's the necessity condition. Necessity condition. So if a vector quantity are there, if they to be the added and satisfy the triangle law of vector addition, not only of your the triangle law, parallelogram or the polygon or the law of the vector addition, then we will call that that is your the vectors. Now the question comes, what is the angle between your the vectors? How we will determine the angle between your the vectors? Suppose this is a vector and this is your the vector. Suppose this is your the vector and this is your the vector. Suppose this is a vector and this is a vector. So this is a vector means this is its initial, this is the final, this is the tail, this is your the head, this is your the tail, this is its the head, this is the tail, this is the head, this is the tail, this is the head, this is your the tail, this is your the head, this is your the tail, this is your the head. So the angle between the vector means it is the angle between their directions, and which to be angle between tail to tail or head to head. The angle between tail to tail and head to head. You see, this is your the tail, this is your the tail. These two tails are coinciding here. So this is the angle between here the vectors. and this is your the head, this is your the head. They are coinciding here. This is the angle between your the vectors, between the vectors. And you see this is the tail, this is the head, but with this head the tail being your the started. So, what the condition to be satisfied? Between the tail to tail or head to head. Means with this one, if the similar type of the vector will be taken here, this vector, make it slightly greater, this vector. If this vector and this vector to be taken, so if this is the p vector, this vector is also the p vector, because its magnitude, its direction are here the same. So, this vector is equals to of the that vector. So, between this and this and between this and this will be the same, because this vector has its the tail here and this vector now also has the tail here. So, this is the angle between your the two vectors. Or in the other way, you have to remember the angle between their direction. So, which one will be the direction? As I said earlier, a train is moving. In which direction the train is moving, we will say the direction in which the head is going, means the engine is going. The engine's direction is your the direction of your the whole one. As in your the family, suppose you are the eldest brother or the sister of the family. As you will do according to your brother and sisters will do. Therefore, they will say that you are the engine. If you will go in that direction, the others will move in that direction. I remember this thing are not saying you are the parents. So, if this is the vector, this is its the direction, and this is the another vector, this is its the direction. As I said in my method, angle between the directions, this direction will in this way, this direction is in this way. So, this is the angle between them. Some student will say that, sir, you said this is the angle. Now you said, sir, this is the angle. This is the smaller one. This is the bigger one. Is it the smaller and the bigger, student? No. If this angle is your the 30 degree, this angle is also your the 30 degree. So, the angle between the vectors, that is the one way. Or you can say the angle between tail to tail, or the angle between your the head to head, that is your the direction. Suppose according to your the screen, a vector is likewise. This is your the plane. So, this is its the tail. So, this is the angle between your the of that vector, because this vector with the plane, the angle which makes. Suppose we will take another one. This is your the north, this is the south, this is the east, this is the west. So, what will the direction of your the any physical quantity? Either in this direction. So, what is this direction of that physical quantity? You will say that it is in your the east and the north. So, we can say this is the east north or the northeast. Suppose one is in this way, then we will say that it is in between your the north and the south. So, the north and your the west. Suppose one is the in this way, then we will say that this is the angle between your the east and your the south. Suppose I will say this is one. We already taken this is in the east north. Suppose you will say this is another vector, this will be say the east north, then there is a confusion. Then at that case, what angle it makes we have to count. Suppose this angle is your the 30 degree. Then we will say that this vector is 30 degree towards the north from your the east, means this is your the direction, means it is your the 30 degree in which direction? Towards the north, 30 degree north of your the east, means from the east it makes your the 30 degree towards your the north. Therefore, this is its the direction. So, the direction is always corresponds for a vector, means one of its the surface of if you are taking in the 2 dimension or you are taking in the 3 dimension. So, you see in your the screen, if this is the vector, this is the head side because the arrow mark is there, and this is the starting one, this is your the tail side. Therefore, from this tail to the head, it is nothing but its magnitude, and this is its the angle. It may be the theta, means it may be 30 degree, 10 degree, 40 degree, whatever it may be. But now there is a confusion here. So, if this angle is your the say 30 degree between your the heads, this is not your the angle between your the heads. If this is your the 30 degree between your the heads, sir, this is not the angle between your the heads. Yes, but that angle is your the 330 degree, because this total one will be your the 360 degree. But you remember that whenever the angle to be the taken, that angle, if it is the theta, that must be less than or equals to your the 180 or greater or equals to your the 0. Sir, where it is your the 0? When they are in the same direction. You see 2 meter and this 3 meter are in the same direction. Means here the theta is equals to your the 0 degree. In this case, one vector, that this is the starting one, from this to this direction is your the 2 meter, and from this to this is your the 3 meter. So, it will be slightly less, because from this to this already 2, this is your the another 1, so this is the 3. So, this vector is going in this direction, the second vector is going in this direction. What is the angle between them? And here the angle between them is your the 180 degree. And what happened for this one? This is your the 2 meter, this is your the 3 meter, this angle is your the 90 degree. So, here the theta is your the 90 degree. So, the angle between the two vectors will never be your the more than of your the 180 degree. If the angle comes your the 180 degree more, then you have to subtract the same one from your the 360 degree, then the what the smallest angle will indicate, that will be the angle between your the two vectors. Are you clear to my students? What is the scalar? What is the vector? As we know earlier, scalar is your the only magnitude, vector has your the magnitude as well as your the direction. But what the new things came to know today, that is your the vectors must be satisfied the vector law of your the addition. But for your the scalars, they will satisfy the general addition of your the algebra. Means like your the 2 ampere and your the 3 ampere. 2, 3 when they to be added, that will your the 5 ampere. This is your the 3 ampere and this was your the 2 ampere. This is your the scalar and your the vector. Next we will discuss what are the different types of the vector. Now we will go to discuss about the types of the vector. So, earlier we discussed what is the scalar, what is the vector, and what is the necessity condition for your the vectors. If a quantity has your the direction, then we cannot say directly that it will be your the vector quantity, because there is the example of your the current. Similarly, the example of your the pressure, that is also has your the direction, but it is not your the vector one, that is your the scalar one. Now, we will go to discuss about your the classification or your the types of the vector or types of vector in form of the orientation. In form of the orientation. So, types of the vector, the very first one is your the equal vector. First one is your the equal vector. So, equal means when the question of the equal comes, there must be your the two things, must be, and it may be your the more than of the two. But equal vector means there must be or the at least of your the two vectors. Suppose this is a vector and this is your the another vector. Then these two vectors, initial and the finals of your the same length. When the two vectors have your the same magnitude with your the same direction, not only your the two, I said for the equal at least your the two. Suppose there is another vector likewise, there is another vector likewise. Means here we will say there are the four vectors of the same magnitude with your the same direction. Then all these vectors are called as your the equal. So what will the definition? When two or more vectors have same magnitude as well as same direction, You see, if this is a vector named is A, this is your the B vector, this is your the C vector, this is the D vector. Then what will you say? A vector, comma B vector, comma C vector, and before the end vector it will not your the comma with the and, D vector are equal. So by taking this concept, you will make your the parallel shift. Suppose this is your the axis, we have taken a vector. Here. The same vector, if it will be placed from the origin, means from this to this and from this to this, the magnitude is your the same, and this one is in this direction, this one is in this direction, means along the same direction, means the angle between or among them is your the 0. Then this vector, if it is the A, then this vector is also your the A. Then we will say that this vector is parallel shift of this one, or this one is the parallel shift of your the next one. Similarly, suppose you will take your the another vector likewise. So these all vectors are the same. So this vector representation with this one, this vector representation with this one. So they are called your the parallel shift, and this is the most important while we will go to discuss about your the triangle law or the parallelogram law or your the addition of your the vectors. So this is your the first one is the equal vector. The second one will go for your the negative vector. So negative means what? Just in its the opposite, that is your the negative. Why you are giving always the negative answer? Means not in your the direct but in your the indirect way. Suppose this is your the vector. So negative means both. For the negative, not your the two or more, only your the two vectors. Be it for the negative, one is compared with your the another only. So if you will take your the another vector likewise, then this vector, if it is your the A, this vector is your the B. So this vector is starting from here and ends here. This vector is starting from here, ends here. This is your the tail end, this is the head, this is your the tail, this is your the head. So in both the case, you see the magnitude between your tail and the head. Here also between the tail and head, if between tail and head is the this one, if we put these two fingers here, means your the parallel shift. As this side and this side and this side, the length are the same, but in the same direction, we said that is the parallel, but here the length is the same, but not the direction. Sir, how the direction is not same? You see the arrow mark is to the right, and here the arrow mark to the left. So the right and the left, just they are in the opposite, means the two vectors have the same magnitude but in opposite direction. So definition is when two vectors have same magnitude but directed in opposite direction, then one is negative to other. As for the example, A and the B are the two vectors, so we will say A is negative to the B, B is also negative to the A, means A vector is negative to the B vector. So, if you will take its modulus and its modulus, A vector modulus is the A, here B vector modulus is the B, with the minus sign with the modulus always give you the plus, so that is also the B. So, A is equals to B. What I said earlier, without the vector, if the same one to be the represent, that is its the magnitude. As I said, if it is the P vector, if you will write only P, means it is the magnitude of the P vector. This is the A, means it is the magnitude of the A vector. It is B, means magnitude of the B vector. So, the both the vectors have here the same magnitude, but the direction is opposite. On the another way, as you said, one is negative to another. On the other way, you can say B vector is equals to negative of here the A vector. So, this is your the equal vector and your the negative vector. If you will go through your the screen with your the slides, you see this is your the parallel vector. A vector and B vectors are taken. So, they are your the parallel vectors, but they are not your the equal vector. Now, you see this is the equal vector. A vector and B vector are taken. So, A vector direction and B vector direction are the same, and their magnitudes are also the same. Similarly, for the another P vector and the Q vector, the direction is the one side is the direction. Suppose these are the equal. One will say if this is the one vector, then which one will be the equals to that one along the same direction. Suppose one will take this is the vector, which one will be equal to that one along the same vector. So, that is your the equal vectors. Next we will go for your the parallel vectors. Next one is your the C, parallel vectors. Parallel vectors. For the parallel vector, this is one vector, this is another vector, this is another vector, this is your the another vector. So, for the parallel vectors, the vectors must be in your the one direction, means they have the same line. They have the same line of action. All the vectors are from left to right. They have the same line of action, but their magnitudes are your the same or your the different, that depends. Means from this to this, we are say that they are the equal, but they are the parallel. For this to this, they are your the not equal, but they are parallel. For this to this, they are not equal, but they are the parallel. So, this is your the parallel vector, this is your the negative vector, and your the equal vector. About these three vectors we came to know. So, what are the net topic we consider today? One is the scalar, one is your the vector, how the scalar and vector are the variant, how they are the varies. The difference is that the vectors must have your the direction and they should satisfy the vector law of your the addition. This is the most important. Then we will come to know what are the classification of the vectors. This one is the equal vector. Equal means magnitude is same and the direction is same. For the negative, the magnitude is same, but the direction is opposite, and for the parallel, they have the same line of action. Okay, thank you very much, and make it the practice and be ready for your the next class. Thank you.